Hello, everyone. Thank you for attending today's webinar. We're going to talk about topography analysis and how we are using it on RatedPower. Let's wait for 2 more minutes for more of the attendees to get online. We're using GoTo webinar tool. I hope it wasn't too difficult for you to connect. This session will be recorded as always and will be published on our YouTube channel and our homepage. So if you need, you could always go back and review. I'm seeing more people joining. Thank you so much. It's during the summer vacation time, so I'm very glad that there are still a lot of you working as I do. And I hope the heat waves are not affecting you as bad as I am in Madrid here, Spain. Okay, let's wait for 1 more minute. Um, Anytime during this session, if you have any questions, you could send through a question on the interface of this webinar. And also, I believe you could chat with me or each other in the chat box as well. There is another panel here. Um, I will be answering all of the questions at the end of the session. We have a Q&A session left at the end. We've already received one question beforehand, actually, so I'm going to start from that. Actually, a lot of the content in this session will answer that question directly, but in the end, I will summarize everything again. All right, so we've already waited for 2 minutes. Without further ado, I'm going to start today's webinar. We will talk about topography analysis today. And first of all, a self-introduction. I am Ming. I'm the technical advisor working in RatedPower. I've been here for over 3 years, and I've been working in the industry for over 7 years. I have originally worked in Japan for 3 years, and then more than 3 years, and then moved to RatedPower. Here, I'm in charge of APAC region that covers China, Oceania, and Japan. So considering Southeast Asia and Japan and China's conditions, you all probably know terrain can be very challenging there. And there are a lot of mega solar projects built on mountains as well. And I think that's give me a lot of insights on the topography, especially to be presenting today's session to you all. So today's session will be divided into 3 sections. First, we will talk about how to handle site data, especially how to import different resources into RatedPower. And in the second chapter, I will mention how traditional workflow looks like. I'm not an expert in this field, so I will just summarize on what I have seen. And with the tool, only is limited to me on hand right now, especially with QGIS, which is an open source tool. And then finally, we will talk about how RatedPower is approaching these challenges and the deliverables that we're giving that are valuable for our users. So the solar farms on the challenging terrain are normally built on a lot of slopey areas, just like the background is showing right now here. It's on a mountain somewhere in China, and as you can see, we have no flat terrain to actually easily build our solar plants, and they are mounted on the very hilly surface. And so before we're doing these plants, we will have to do several steps to analyze our topography and to figure out what is the best grading plan. And here it goes with our several steps to come up with this construction plan. So first of all, we need to collect and prepare our site data. And these data covers with, for example, our survey with the on-site mapping. Sometimes we have the drone data, sometimes the digital elevation model from public resources, point cloud from drone pictures, and sometimes we do have to do some on-site survey and figure out the soil conditions and do more site investigation on what is the surrounding look like, what are the trees look like, etc. After we have prepared the data, we will move on to the next, which is to define our solar layouts and figuring out our grading philosophy. So this step normally goes to our origination team. They will generate a conceptual design, normally is two-dimensional layouts. And in this design, we will already account for the road spacing, shading, access roads, etc. And then we're also keeping everything constructible by looking for the steep area where it's more hazardous or not favorable for our installation and keeping them out from our layout. And then spots the grading philosophy on this stage. And once we have figured that out, we will create this after leveled surface and overlay our two-dimensional layouts on this terrain and generate our three-dimensional layouts. From the altered terrain and the original terrain, we can then compare the surface and figure out or quantify how much of the earthwork we need to do. And finally, we're coming up with the construction plan as an output based on the last grading plan that we have came up with. And in this step, sometimes it takes multidisciplinary experts to cross-check what is the most balanced and optimized grading plan, what is the one that saves us the most cost, on this at the same time giving us enough energy and production in the future. So right now I will talk a little bit about how to collect data and prepare them, especially when it comes to rated power. So when it comes to the data preparation, I've mentioned earlier, we sometimes need to do on-site soil investigation, the drone photography. But when it comes to the public data source, we have the first two available. Um, the digital elevation data or model is sometimes using SRTM. This is an acronym for Shuttle Radar Topography Mission, and it's actually used for Google Earth, and it normally carries a resolution of 30-meter by 30-meter. This is also freely provided by RatedPower that all of our users can automatically use. And then we also have LiDAR data. It is a higher resolution. It's normally available from local governments, such as in Spain, in Japan, or in the US, Oceania. We all see these public available data. And today I will give you a small tutorial in a video that covers how we could transform these LiDAR data into rated power. It's actually presented in this tutorial on Health Center of Rated Power that everyone can learn step by step. And here I will just present you in this short video. The actual work took me around 5 minutes, but I have shortened it into 2 minutes, and I will explain to you how to do that. So let me switch it to a higher quality first. First, we are doing this site in Spain. So I have gone to the site IGN and I was looking for the map or the boundary of my site specifically. Once I have found this map, I can then download this LiDAR data in a TIF file. Then in an open resource tool that I've mentioned earlier, QGIS, you can add a raster layer by this TIF data. Once it's uploaded, it looks like this. And it's very important that in all the local LiDAR system, they're using their local CRS as well. So to read it correctly in RatedPower, we will have to incorporate with what's used in RatedPower. I have just copy pasted that CRS code from RatedPower. Now I'm looking for it in QGIS 32630. Once I have reprojected it to the correct location, now you can see my boundary is located in the same place as my TIFF layer, raster layer. So once I have done this, then I can clip this layer into the location of my boundary to limit the size of our data. And once this is mapped out, I can then transform this raster layer into the CSV data, which is um, uh, um, divided into 3 columns, X, Y, Z of every point in this point cloud. So after saving it as a XYZ file, we can open it in Excel, or just now I open it up in VS. And you can see those 3 columns. And then I can upload it into RatedPower just like this. We can drag the different bars to represent for what are the steepest slope, how the slopes are presented, the color maps, etc. And the steeper it is, it's going to be in a darker color, and the shallow places or flatter terrain will be represented in green color. So this is a full procedure how you can find resources on public data base and convert it in a freely tool like QGIS to a CSV or XYZ format, and then upload it into RatedPower instead of using SRTM, the Google Earth data, which has 30 meters of resolution. All right. So once the terrain is uploaded, we can visualize it in a 3-dimensional view. And this is exactly the site boundary that I'm looking at. And I can see that it's a very hilly terrain. We have some valleys there, but we also have some relatively flat terrain on the top of these hills. All right. So what if we're using a traditional workflow and considering using AutoCAD or QGIS to figure out those slopes and challenging terrains and the shaded terrains? This would be the procedure that we follow. First, our origination team comes up with a 2-dimensional solar layout, conceptual layout, completely not very advanced. It probably contains your module layouts, your power stations position, and your access road, but it does not incorporate our terrain, the drainage plans, the retention ponds, etc. And then at the same time, our civil team probably are using AutoCAD or other tools, Civil 3D, to come up with this grading plan and drainage plan at the same time. And once these are completed, we are laying or overlaying this solar layout to the after leveled terrain to come up with our 3-dimensional plan. And based on this plan, we are going to optimize our layouts, our civil work based on the financial or production outputs. So as a first step, we generate our two-dimensional layouts. This is actually what I did in RatedPower already. We're seeing the modules, roads, and the power stations. So this is an area of 176 hectare located in Spain. We're using bifacial modules and fixed structures. The peak power of this site, if we do two-dimensional layouts considering no restrictions, would be 257 megawatt DC. And for future comparison purposes, we are using a capex sheet considering land lease of €3 per square meter for 20 years of the lifespan, and civil work cut cost about €15 per cubic meter and €10 per cubic meter for filling cost in this area of Spain. The LCOE is 44.08 US dollar or euro per megawatt hour for this plant. So in the future, when we're optimizing this plant, especially considering the civil work, where to avoid the installation, where to do civil work, etc., we will use LCOE as a metric to compare and see if with certain strategy we can lower our LCOE. All right. So once we have done with that part of two-dimensional layouts, then the civil team steps in. First, I'm imagining we can do some heel shade analysis, and I did this on QGIS as well. On the left side, we have the visualization of just an hour before the sunset on December 21st. Here we're observing long shadows casted from the west. And the azimuth sun angle for this scenario is 250 degrees and vertical sun angle is about 7 degrees. For the hour before after sunrise, which we have long shadows casting from the east, will be on the right side. This is a representative of where are the shades located, and the azimuth and vertical angles are presented as such. So our goal is to eliminate these very dark places from our installation of the modules, because we already know in the worst day of a year, we have too much shading in this area. So I have done this work on QGIS by polygonizing these shaded area into polygons, and I intended to import them into RatedPower. From the left to the right, I have used I think up to half an hour to just simplify and figure out what are the best polygons to import into RatedPower. Why is that? RatedPower now allows up to 500 different restriction area, so these red restriction zones. And on the left, when we're calculating those shaded area from QGIS, I believe I have calculated more than 2,000 of the polygons. So what I did here was to simplify them and eliminate some area that are too small for installation. So here I have already lost some accuracy of my shades when I'm incorporating into RatedPower. Once it's incorporated and considered those restrictions, our peak power has dropped almost 100 megawatt DC, and our RatedPower has also dropped. So next, I'm analyzing our slopes. On the left side, I have color mapped our slopes on QGIS. Again, the green area are the flatter terrains that goes up to 14 degrees, and with the red area up to 56 degrees. So my goal is to eliminate all the slopes that are more than 15 degrees, which are very challenging for our installation in the construction. And again, I had to simplify my plan when I'm polygonizing this raster area to RatedPower. So I think in this plan, I have counted about 1,700 features, and I have simplified them less than 500 into rated power, but that is already enough time consumed for me. Again, half an hour about, and rated power is also struggling to compute our results just because of how many polygons and how complicated they are as an input. Now, reading the results, our peak power has dropped again 90 megawatt DC. We're ending up with 88 megawatt DC as peak power. So finally, if we read through our procedures, first, I have analyzed the heavily shaded area and then slopes area, and I want to take them out from my two-dimensional layouts. So as a civil work team, I'm coming up with the surface grading plan. This probably uses Civil 3D or other more expert software and takes more hours and more days to complete. And after that's considered, we're considering the drainage plan, the changing of the internal roads, etc. We revise them based on the best outcome, balancing the cut and fill amounts in the civil work, and then overlay our two-dimensional layouts to the 3D terrain finally. And in the end, after all the revising and optimization, we are ending up with a construction plan and civil work estimation. And based on this estimation, we can come up with our capex cost. And based on the production, we get the LCOE. Our financial team can then optimize our LCOE. So this is a very lengthy procedure. And when it comes to the civil work or the grading plan, sometimes it looks like this. So on each cross section, we have to figure out where we're cutting, where we're filling, and this is normally done on the third step using Civil 3D and other software. So what we have done today in this webinar is I did not consider the grading plan because I do not even have Civil 3D to start with. So what I did was just to eliminate both shaded area and sloped area on rated power. And I've combined those restriction zones and ended up with this three-dimensional plan in the end. You can see that all the north-facing slopes, basically very steep, are eliminated from our final results, and those valleys are also eliminated. In the end, we're ended up with some area on the top of the mountain or at the bottom of the mountain. Although I don't think the northern area of our plan will receive a lot of sunlight. You can see that it's going to be shaded by the mountain right next to it on the south, and itself has a gentle slope facing the north as well. Although in QGIS, I have set a very gentle limitation, that's why it's kept in our final layout. So now I want to introduce how RatedPower approaches this problem. So remember what we said earlier, layout, drainage plan, grading plan, LCOE optimization, they're all in different steps. RatedPower, we're going to do them all at once. So we're going to account for shaded area, slope area, and terrain undulation. And then after the limitations, we're going to keep it constructible. We will spot where are the places to do some grading and the leveling of the surface and install our structures on top of them. Then finally, as a result, we're giving the civil work estimation of how much of the cut and fill are going to be needed, and financially, what is the LCOE looks like. So again, remember our two-dimensional layout has an LCOE of 44.08 to start with. And now let me switch to rated power. On rated power, I have already done a lot of designs. So let's look at the very first one, rated power approach, when we're considering both sloped area and shaded area. So instead of importing all of those complex restriction zones, now we can go to the topography tab directly and apply some limitations. Here I have applied, for example, we do not want any north-facing structures to be installed because they're simply not receiving the best condition of the irradiance. For the south-facing slopes and east-west facing slopes, I have applied the same limits, which is an equivalent of 15 degrees of slopes, same that I've done in QGIS. And once I have done these, the software is spotting all the structures that are exceeding all the limitations that I've introduced just now, and they are colored in green. These green structures will be finally eliminated from our final results. And if we look into the 3D map at the same time, we will see that just as we saw earlier, by incorporating the restriction zones, we have left with structures basically on the southern bottom of the mountains and on the top of the mountains. And at the northern part of our plants, because they are either too steep or they're facing the north, most of them are eliminated, just remaining a few. All right, so this is the first design that I've generated. And if we look at the LCOE, it's going to be 44.08 this as well. Why? Because we are not considering any civil work yet, just now. And if we go back to our project folder, I have prepared the other design results where we're incorporating other conditions. For example, if we are using 5% of the north-facing slopes instead of 0%, we will end up with higher capacity, which is 99 megawatts DC. And as you can see with the results, we have more of the structure mounted on the northern part of our design and some here and there inside of the hills. And if we're incorporating an even higher 10% of north-facing slopes, we will end up with 121 megawatt DC, and we are observing more structures being installed at the northern boundary of our site. But again, when the hill is facing north with a steep slope around this area, we're not choosing to install any structures. Now, if I consider doing some earthwork in RatedPower, here is how it works. In topography tab, again, we will apply some earthwork by giving a new limitation. So if we are allowing, for example, the software to consider any structure with the slope under which up to 15 degrees to be normalized back to around 5 degrees to north-facing structures, north-facing slopes, and with south-facing slope and east-west-facing slope, we're considering up to 30 degrees to be normalized to 15 degrees. If we run the design now, the software will check all the structures under which the surface is up to our standard and considering doing civil work. The civil work will be considered in patches instead of under each structure. So when we identify several structures adjacent to each other that requires civil work, we will then make a platform, and this platform has a total cut and fill amount showing on the interface directly. In the end, we will sum up all the cuts and fill amounts and deliver them in the bill of quantities and our financial analysis. So considering all this civil work, our LCOE has increased. But in our 3D map or in our final peak power, we're observing a much more capacity installed, and we can see in the 3D layouts a much fuller design in the end. So that is how the civil work is being considered in RatedPower. If we go back to the project folder, I've already considered the different scenarios. For example, if we consider normalizing up to 30% and 100 centimeter of undulation back to 50 undulation, we are ending up with 217 megawatt DC. If we make it stricter, so from 45% and 80 centimeter of undulation back to 15 degree and 50 centimeter, we're ending up with 132. So with stricter civil inputs, we're getting less capacity. But where is the sweet spots where we're balancing our civil work and the production? Then that comes to the very important metric of LCOE. If I compare all these designs with or without civil work considered, in the comparison view, we will see they, as a result, what is the LCOE for each of the design. If I look for the smallest LCOE across all of our designs, we will see that when civil work applied with up to 30% of the slope rated to 15 degrees, we're ending up with 44.07 of the LCOE, which is slightly smaller than the beginning where we're having 44.08. So by trying different scenarios of the limitation, the software can be is smart enough to consider the layout, financial outputs, and your civil work in one place, and the user can optimize them at the same platform and coming up with the best plan. If we look at the 44.07 LCOE design, here is our results. You might say, oh, this is not very constructible because we have a lot of structures singled out in different area. We're not going to invest all those money to consider them being installed where they are far from the batches of the structures. Well, here we can then use the layout editor where we can eliminate different structures and reconfigure our roads and power stations layouts. We have done many webinars on this, and for today, I'm just going to show you very quickly. For example, oops, for these structures, okay. These structures, they're actually very singled out in this area. So what I can do is to select them. I can do one by one and click on delete, and they will be eliminated from our final results. And I could also use Shift plus the dragging. I'm not sure why the Shift key today is not working very well. I can, by eliminating all these singled out structures, I can make sure that my design is constructible. Other than doing that, I could also change the road layouts and to apply it with what will look like for my final design, incorporating the drainage plan as well, considering how the contour line looks like. So for this design, after I have changed some structures and roads or power stations, I can then validate if it can be proceeded into the simulation. Now the software says the validation has completed without any error message or warnings. Then I can generate it as a new design. Once generated, we will see the new set of data or results incorporating all the modification that I've done just now to all of my structures. This new design will be saved as an edited version. And if you want to keep working on the structures layouts or any of the elements that I've mentioned earlier, you can then click on edit layouts and enter that interface that I've shown you just now and keep working on all of the results. All right, so once I have deleted some structures, you can see that my LCOE is going even lower um, because I'm reducing my cost of installing more structures, and the production probably doesn't change much from eliminating all these structures. And most likely these structures were built on a platform that's requires civil work, and by eliminating them, I can also eliminate my civil work amount. By doing this, my cost will be furthermore reduced. All right. So, as a conclusion, the civil work will be considered in RatedPower as a one-stop shop together with our layouts and our financial results. So um, compared with the traditional workflow, which requires collaboration across teams, which are maybe origination teams, layout teams, civil work teams, and financial teams that has multidisciplinary expertise, RatedPower doesn't take those. But anyone can complete this preliminary study of the early stage civil work and layouts and the financial results on our platform. And by incorporating all these procedures into one platform, we can optimize the design earlier on and mitigate our risks, no matter it's the timeline risks or civil work risks or the financial risks. We can all control them better in the early stage because we have a better understanding of what is the best grading plan, what is the percentage we should go to, and how much of the slopes we should desert and how much of the slope worth us doing civil work and installing more structures. These would be the advantages of RatedPower and leveraging the cloud service to help us making our civil work and preliminary studies faster and more reliable. All right, so these are all the slides I have prepared for today. We have about 5 minutes left. I will now dive into the questions session. So we have the first question we have received was actually from before this webinar. How RatedPower will work for terrain-based PV projects for slope analysis and optimize the cut and fill estimation for fixed structures and tracker. And this is from a user from ours from Tata Consulting Firm. So I think from this session, you would have a basic understanding of how RatedPower works. Basically, we are uploading our topography first. If not, you can use the Google Earth data. And then in the topography tab, that is where the users can introduce what is the limitation that they want to consider for the topography analysis. North-south facing slope, east-west facing slope, and terrain undulation are the three aspects that we're giving users the options to consider. And then on top of the restricting structures from installation, we then give the users the option to consider some earthwork. And then these earthwork will be applied up to the limitation that the users are typing in here as well. And finally, we are having the total cut and fill in the BOQ and considered for our financial analysis. And to your question, how do we optimize the cut and fill estimation? Then I think it's the strategy where we're using the LCOE to figure out the balance between the civil work and the deserting some area from completely installing structures would be a great metric. So by trying out different restrictions, different limitations, we can end up with different LCOE, and then figuring out the lowest LCOE is a good way to configure the best civil work as well for your projects. So we have another question submitted during the session. Do the cost and LCOE consider electrical cost? How the electrical wiring looks for this site? Okay, so first, how does the electrical wiring looks like? If we go to the last one that I've done, we can see up to the string cables wiring. So for those structures that are located very far from the blocks, you can see that the string cables are going to be stretched very far. Are they considered? For my financial sheets that I'm using, I don't think it's considered per cable. It's considered per kilowatt peak. That's not completely accurate. I encourage you to always consider the cables by the unit price of the cable length. And the users can introduce these CapEx sheets by themselves and considering each item and selects the correct units that's mapping out our BOQ in the library of the CapEx sheets. In the private database, you can create a new data sheet. And for example, if you want to consider the cable length, if we search for the string cables, I can then incorporate the unit price per meter for this type of the string cables. With that being said, that is a good way to also understand why in the layout editor I wanted to take out these single structures from being installed. Considering if we consider all these cables, the longer the string cables, obviously the higher the price is. And if we eliminate or restricts these structures being installed, I'm sure the LCOE will go lower. Okay, and then another question is, could we use grading for detailed engineering for construction plans? I think for construction plans, if I go back to my slide, what I understand from talking with a lot of our users day to day, they would need a cross-sectional view of cut and fill like this. In RatedPower, all of our civil work will be represented in the platform uh, in the platform result. So that means you probably will end up with some walls here and there that are not completely realistic. RatedPower's civil estimation is more targeted at the early stage of optimization. It's more of a numeric results instead of really providing you that cross-sectional result for the entire site that people are generating from Civil 3D, like this one is showing. So I would say that's better to use RatedPower on the early understanding and risk control instead of the final output of construction plan for the grading. Okay, final question. Sites measure topography can import this in software and perform analysis. Yes, as I said earlier, when we're converting the public data source, I converted from a TIF file. I believe if you do similar procedure in QGIS, you can do the same. So it's just convert from different formats into a point cloud that can be extracted into an XYZ or CSV format. Those are the formats that RatedPower accepts. And sometimes our users using drone pictures, I do believe if you could export those drone pictures into XYZ 3 columns into a CSV format, it wouldn't be a problem to upload to RatedPower either. So site measurements can be uploaded and utilized into RatedPower. Oh, another scenario is sometimes our users use contour lines from AutoCAD. That is also very easy to convert into CSV format. And we have a similar Help Center article, just like this one, in our Help Center as well. You can search for example, keywords such as contour line, how to convert contour line to CSV, etc. And you can follow that tutorial step by step. A lot of them are overlaid with the video that I was showing today, though. Okay, so I think I've answered all the questions and we are just about time to finish. And so thank you all for attending today's session. I hope you had a basic understanding of how RatedPower does the topography analysis and our advantage of bringing all the results in one space. And you can visualize your results and compare them, and by doing this, you can optimize your design in the very early stage. If you have any questions in the future, feel free to drop an email to support@ratedpower.com or contact me directly. Again, our webinar will be recorded and uploaded to YouTube channel. Feel free to review it when you need it. Thank you all again and have a nice day. Bye bye.